Hello, everyone. Thank you for joining us for this Summer of AI event. And I'm Shanika Glover, your host, and I will help facilitate, take attendance, and collect any questions during this discussion. This event is AI in an Internship Program presented by Michelle Rome and Mike Sommers. They will discuss how they have approached AI in the ATLAS Internship Program. Several students developed projects will be highlighted during this presentation. And Mike and Michelle will also be able to present on how they are using AI to further their personal studies and techniques. If you continue to enjoy this event, we have more Summer of AI events next week, which is on our calendar. And then also, if you have any questions throughout this discussion, please feel free to drop it in the chat via Zoom, or if you're in person at the end of the session, you'll be able to ask some questions. So thank you again for tuning in, and thank you, Michelle and Mike. Good luck.
Good luck. Thank you. I know, just the amazing collection of names today. Hi, thanks for coming today. We do have a presentation prepared, and I enjoy casual presentations. So if this turns into a conversation, I am totally cool with that. So I'm going to go over some beginning things and turn it over to Mike. So just to introduce ourselves, and for those who don't know, my name is Michelle Rome. I'm an associate director in ATLAS, which is the IT unit for the College of LAS. My background, I have a bachelor's and a master's in computer science, and I've been at the university for almost 24 years, I guess, like next week. And I worked some outside of that. I'm not going to say how long because that's too revealing on my age. So I'm going to let Mike, do you want to introduce yourself?
Yes, hello. My name is Mike Sommers, and I am a senior software developer for Atlas, and I work under Michelle in the app dev team, and we do a lot of web apps for campus and things like that. But I also do this intern thing, and we've been doing this for a while, and I am sort of their I sort of lead the intern teams as like a tech lead. And there's another team I also lead, which is like the virtual reality group. And so my role is usually to meet with the students every week or the interns every week and sort of guide them along, answer technical questions, make sure that they're making progress, make sure that they have a project at the end of the semester. Because ultimately at the end, we want them to have some kind of working prototype, like an app or something like that. And I kind of make sure that they get there in the end. And, sometimes they'll have ideas and I kind of have to, narrow down what they're doing and make sure that it's feasible within the time we have. So I'm basically the tech lead for the interns. And so I'll be answering questions and maybe chiming in. And at the end of this, I'll show you some cool stuff that's sort of unrelated, but we'll talk about that when we get to my part. So thank you.
Thanks, Mike. Mike, you did, I don't know if I should have shared my slides. You did a good job of picking and pulling some of the information I was going to share too. So one of the things that I do is oversee the internship program for LAS. In its current form, the internship began in 2016, and there have been nearly 1,600 LAS students who have gone through the program to date. The goal for this is to give LAS students some hands-on experience working with technology in a professional setting so that when they graduate, they are more prepared to compete for jobs. The goal of the program is to really supplement what they're learning in their traditional curriculum, not to try and replace any of that. So it's really hands-on. Those 1,600 students have not all been embedded in ATLAS. So One of the things, just to kind of clarify, is we have worked with partners across campus in Champaign-Urbana, some small businesses, the iVenture program with local startups, and some nonprofits to really find people in the community who are interested in giving these opportunities to the LAS students. But then also in return, they are getting some help from the interns. On top of that traditional internship experience, we've also dedicated some of the time and some of the ATLAS teams to doing some research and development types of projects. This has really helped ATLAS start to uncover and learn some advanced areas. As most people on campus, many units on campus, there's way more work than the current staff can do in the amount of time that there is. And so the students on these R&D projects have really helped us make some headway in that area. Some examples of the research and development projects we've done some deep dive into a few data projects. We have done some experimenting with typing rhythms. We have played around a little bit with facial recognition, and really, as Mike talked about, AI and machine learning are the two areas right now that we have some R&D projects happening with. The internship format is for a semester. Students commit to about 10 hours a week for the length of a semester. And we do try to wrap up by reading day so that they can focus on finals. And the semester structure is kind of the same for everybody. They start off with some training materials or experimenting around with the technologies that we're working with. And Mike referred to himself as kind of helping guide them. And we often refer to him as a mentor. So he's a tech mentor leading some of these. They're not exactly independent study projects, but similar to that. The client placements beyond that all kind of start off differently depending on who they're working with, what they're doing, and what that client has in store for them. But some examples of other internship projects, students really are great for extra hands for basic tasks that need to be done in units. In LAS, we've had quite a few students help units maintain their departmental websites or help generate digital newsletters and look at analytics for that. Those have been excellent experiences for the students, and it takes a little bit of workload off of often a administrative staff in the units. Another thing is when you have low priority projects, a lot of units, I know mine all do, have projects that never make it to the top of the queue. That would be nice to have. And those are other great intern projects. So with the AI specific projects, we started working with AI in spring of 2023. In fall of 2023, we started working with a local on-prem LLM server and GPU server. And then it's really hard to believe that we're wrapping up our 8th semester of these type of projects. So to go a little bit deeper, ChatGPT was released in November of 22 publicly to general public. And I think probably many of you on this call or in this session started playing around with it, or you knew people who were playing around with it. It was hard to go anywhere or listen to anything and not hear about ChatGPT. So we jumped on that bandwagon with interns as well and started giving them some very specific things. We played around a lot with prompt engineering. We really tried to test the extremes. Would it answer the political questions? What did it seem to know, what not know? My supervisor at the time was a tenured math faculty, and we started asking it questions about awards and accomplishments of other faculty on campus. And we found out really quickly that ChatGPT did not know what it was talking about and lied often. So we got into that hallucination part. And that I'm kind of surprised we kept going with these projects once we found out that it would lie about faculty awards. That was a serious subject. So as the new AI engines became more available, we started trying them as well. And so we would create a test and run it through multiple engines, and students created some reports comparing behaviors and results from those different engines. And
Yeah,
it,
Michelle, we also had them play. We had them play games, very simple,
yes.
like tic-tac-toe. We had them try, having the LLM create a tic-tac-toe board and seeing how many moves it will take before it starts to hallucinate and give you the wrong results. Then we tried like Hangman, we tried tic-tac-toe, maybe I can't think of any others, but I think we tried those as sort of the baseline tests for these different models to see how well they would do.
Yeah. Could we give enough prompts to get it to play tic-tac-toe appropriately?
Eh,
Uh,
Yeah, it did. In the early ones, yeah, the early years, it didn't. It didn't. They had low context windows, so they faltered pretty quickly.
Yeah. So after we had kind of a good handle on that, we played around with that for maybe a couple of semesters. We started getting into wanting to programmatically work with stuff. And at that point, um, and rightly so, we were not comfortable with sending a lot of our information to ChatGPT and all of these other things that were popping up. So Mike and our infrastructure team, Atlas acquired a small GPU machine and really started playing around with that. Mike, do you want to talk a little bit about your Llama and Mixtral? And you were changing them so fast,
Yeah,
you couldn't
yeah,
keep up.
yeah. Right. So we got a server that contained four A100 NVIDIA GPUs. So these A100s are um, I guess they're not consumer level, they're server level, professional level like GPUs, and they have 40 gigs of VRAM each, and they're very high powered to do sort of the matrix calculations that you want to do for these large language model inferences. So we got this server, it's a great server, and we're able to basically we were able to basically fit like one of these open source models. So we started experimenting with these open source models that you can just download, and there's software to run the inferences on these open source models. So initially we tried, I think the first one we tried was Mistral, um, from yeah, no, yeah, Mistral is the model name, but also the company is Mistral. So this is a French company, and we tried Mistral. I think it was eight gig, um, 8 gig parameters. Uh, so we tried this model, and we basically you can hook it up to a single GPU, and it runs directly on the GPU, and it runs a lot faster than the students would be able to run on their local laptops. So we set it up so that you can just query the server like an API. So they query the server and get a response just like you get a response from, like ChatGPT or one of the other models, professional models. Um, so this allowed us to sort of do this locally. How good are these like open source models? Test them out locally. So we've been trying Mistral, and several months later, 3 or 4 months later, a new one would come out. So these are always changing uh, from month to month, and so we would update them every so often. Every at the end of the semester, I'd usually try and update them, and the students would have sort of a latest open source model working that they could use on their own. So they didn't have to download anything on their computer, and they didn't have to pay. So the issue kind of was that they had to pay for ChatGPT, for the API. You have to pay for Gemini. You have to pay for Claude to access the API stuff, which is what their little web apps would do, is that they would query the server and then talk to the API to get a response from the model. And so this allowed them to
After,
basically do this for free.
yeah,
And
after we did a lot of the prompt engineering and playing of the games, we moved really towards trying to do something real with these
yeah,
systems and create an application. So
Yeah.
we put some items in place and some requirements for them. So we would still start off with the training with prompt engineering
Yeah.
and testing it out manually, and then we moved to using the APIs. And for a while, ChatGPT was nice, and you had a lot of access to those for free. Um,
Yes.
but when you're developing something, you go through those really fast. So, up on the screen right now, I have a list of a lot of some of the basic projects that we started off working with. Mike, is there anything on these? I put these on two screens. These were
Yeah.
kind of our initial playing around items.
So some of these are using an LLM. Some of them are using like vision models. So the ones that identify recyclables and trash, smart vacuum, those are using not an LLM model, but a vision model. Like I think there's like YOLO, which allows you to identify um, different things in static images. Say you want to identify people in static images. So this would give you, it would put a box around it. The model would put a box around it and then put a probability. And then so students would take that probability and be able to, do something with it. Um, let's see. So yes, generate data sets. That was using an LLM. We had to generate some mathematical data sets to do simple. We wanted to sort of generate different types of simple arithmetic, and we had an LM generate like you know adding two numbers together, multiplying two numbers, and then making sure that they're the same, and then um, that sort of thing. Code conversions. So that was using an LLM to translate one code base written in one language to another, and the student had done I think it was C++, and he used an LLM and actually a RAG system, which is retrieval augmented generation system. So a RAG system uses a body of knowledge outside of your prompt, sort of to augment the response. And so he would for that one he took the set of like C++ documentation and took these documents in C++ and then fed it to the LLM and then had the LLM look at a piece of code and translate it into, I think, Python. Or it could have been the other way around. It could have been Python and C++.
I
I
don't
forget
remember.
exactly. Yeah, but so it used the LLM to do this translation. That actually worked really well to translate one piece of code from one language into another. Um, so movie recommendations, that one, so I'm just picking these at random, but movie recommendations, that one was not an LLM, that was using another like NLP model, natural language processing model, like an Expert or Roberta to compare two pieces of text. Initially, we had them sort of do compared um, course descriptions and find matching courses, but you could also apply it to like movie recommendations and seeing how close two descriptions are, and then outputting what are the top five closest. Michelle, do
We really
you? Yeah, go ahead.
I was just going to say, especially early on, students came with a lot of ideas,
Yeah,
and we gave them the freedom to just kind of play around with it and start to use some of these technologies. And that was undergrads, a lot of times don't have a technical space to do some of that. And so Randy was really interested in giving undergrads an opportunity to do that. A lot of times grads get those, but we've got a lot of smart undergrads here too. We also then kind of moved into a little bit more topical focused. We have a couple of projects that we're working on now that have really come from ideas from our dean's office and are trying some proof of concepts. So a key inventory system is a problem that some FNS friends had brought up that they do a very detailed key inventory and audit every year. And so people come in and they have those giant janitor key rings that have got 800 keys on them. And rather than a person sitting and writing them down, can we use any of these technologies to help speed that process up? And I think they had some mixed results on that one, and that'd be a great one to rerun, a little bit later. So I think we did that one last year. So maybe, next year or the year after, try it again as these technologies keep changing so quickly. Currently, two that we're doing are proof of concept using a chatbot, which there are some other chatbots on campus that are starting to pop up. And this is one that students right now are kind of doing a proof of concept to see how it'll work. And then can we identify faculty research themes based on their illinois.edu web pages? So LAS has a new Office of Research for the college, and just trying to figure out, can we see some of that in a way that is harder to do right now, where they have to talk to everybody. So, and then we do have a couple of other projects coming from friends in the registrar's office that would be time-consuming projects that manually they never get the time to work on. And so those are kind of in our queue to experiment with going forward. But
Michelle, can I chime in for a little? Okay.
absolutely.
Yeah, so some of these are really quite cool. So the first one, the quad traffic prediction. So there's the quad cam, which aims directly at the quad. And that's a YouTube video feed. And so what the students did is they took the YOLO model, which is not the LM, but they took a YOLO model, the vision model, and they took static time-stamped images and used the YOLO model to predict, are there people in the scene? And then they would use that to predict when sort of was the largest amount of traffic. Kind of like a Google, if you look on Google Maps, they sort of tell you when a place is most busy. This was doing the similar thing, but actually taking data from the quad cam and identifying people. So that was really cool. So another one, the second one was interesting too. So the student's project was to create, he wanted to take a lecture video that you find on YouTube for a course lecture and plug it into a little app, and the app would give you a summary of sort of the lecture at the end. So the interesting thing about this was it used two different models. It uses the Whisper model from OpenAI, and that was put on our GPU server separately. So we hosted that Whisper model. You can, with the same software that runs the LMs, you can run Whisper. So we had Whisper on there running on a GPU, and we had our local open source LM also running on the GPU server. And so the student was able to first take this, take the audio from this. You can extract the audio from the video and then run it through Whisper. That would give you a transcription of the audio. So you send it out to LM or the Whisper model. Whisper model will come back with the transcription. You take the transcription and add maybe some prompts to it, and then send it out to the LM separately. LM would read the transcript and then return a summary. And they had all this done in a web app in two sort of API calls to make this work. And so that was really cool because we able to use the GPU server for multiple things. So the two proofs of concept that Michelle mentioned, the current ones are the chatbot using OBFS. So that one also uses our current local model, local LM to do that. It uses a local LM and a RAG system. So the OBFS, so they web script OBS website, and they took some of those documents, those web documents, and put them into sort of a document store, a table, and the chatbot refers to those documents to answer questions. And so that's what we've been testing out. So it's using it's not using a professional, it's using a nice simple open source model and then the actual OBFS data to give you answers to your queries, to your questions. And so this is the project we're currently working on. And then again, the research themes is another one that also uses the local language model to identify, from research blurbs that identify identify themes in that research. And again, we're using our local model to do that.
Yeah. I pulled a couple of screenshots from two of the projects that students worked on. One of the things I don't know that we said is when the students are developing these apps, they're not all programmers. These are LIS students, so they have some level. Often there's a CS person on the team, but not always. Mike really encourages them to use Chat GPT or to use these AI assistants to help generate that applications. So one of the first ones we did was a greeting card writer, and the students ended up creating a nice, well-architected application that used a bunch of technologies they hadn't worked with before. So one of the students was very interested in this simulation that generative agents is a project, I think, out of Stanford using using ChatGPT.
Yeah, I
And
think it's ChatGPT.
yeah, we ended up, they really wanted to modify it to use our local LLM so they could run it as much as they wanted, but then also see if they could change the behavior of the people in the simulation. And there was a limit to how many bad guys and what the bad guys could do, because
Right.
that's what they tested first.
Yeah. It was a simulation, like a computer game, sort of. You could see what it looked like. It was a computer game. You had these little characters moving around, and all of it was controlled by ChatGPT. And this came from a paper. Now, it's now a few years old, but it came from this paper that from people from Stanford, that they hooked this up to an LLM and had very specific sort of expecting uh, expecting results back from what is the response from ChatGPT going to give you. And he wanted to replace it with the local one to see if we could get it to work. And actually, that was a lot of work because the local one obviously is not as good as the professional, models that are running huge data centers. So there was a lot of work to like tweak the responses that the local one gave it in order to make these simulation work. But essentially, the entire game world there is controlled by the LLM. It sort of remembers sort of where all the characters are, and then for every time step, it will sort of move the characters and have them do certain things. And as Michelle was saying, there was a little bit of tweaking you could do with like the personalities. It would feed in the personalities of each character, and we sort of tried tweaking them and see if we could create do different things with these characters. Yeah, and that worked out pretty well. It was we got it to work event after a little bit of work there.
One of our early projects, and I still am this is probably one of the projects I'm most impressed by. In the ATLAS Internship Program, the final project that students do for the program is a spotlight presentation. No, the spotlights are on the website. So if you go to our ATLAS website, the internships, there's a spotlight on a lot of the interns who are in the program. And after a while, the people writing those, it starts to sound like just a fill in the blank, replace your name. Or occasionally we would get some that I would reject because they sounded like dating profiles. I like long walks in the beach. We're like, no. So we had a group of students one semester write a generator, which they created a web application where students could fill in information about themselves. And then the system would generate, I think, 9 optional paragraphs. You could regenerate them, you could edit them and save them, and just to kind of help with that. And then I included the slide from the students' end of semester presentations that just talked about all the things that were new to them that they worked with. And this actually, they were able to integrate Illinois login with it. So it was an official thing. So. But this is my last slide. And so we've been talking mostly, and I know this is a summer of AI, but we've been doing some similar things with machine learning projects as well. And Mike has also served as a mentor for those. On the project side, most of those projects, a lot of them were a deep dive into some data predictions with a faculty member, trying to look at some success and more of a research kind of project. So I am going to let Mike take it away, and he's got some cool demos. So if we want to switch over to
Yeah.
his screen.
Yeah, so just a quick about the ML stuff, Michelle. So you had shown a few of those in the AI projects list. So
So
we had
I have
that
them
couple
mixed in
page.
there.
Yeah, you had them
Sorry.
mixed in there, and so those weren't using LLMs or natural NLP models or vision models, but they used sort of predictive. They were more predictive analytics. So if you ever been to Kaggle.com, there's um, a Titanic competition where you predict you have a data set of who's on the Titanic, and the goal is to kind of predict who lived or died. And so that's the predictive analytics question. And so a lot of students are interested in statistics. We have a lot of statistics students, and they're interested in doing more predictive analytics, where they take a data set and they predict some value. They choose the features, do some feature engineering, and then they finally get a predictive result, and they create a website around that. And so the website, the idea is the user will plug in their values for the features, and then they'll do some predictions. So I think we've had, I guess maybe in the spring semester we had someone do like a diabetes prediction. So we had a data set of people's statistics and age, um, income level, BMI, do you eat vegetables, that sort of thing. So we had this large data set, and we want to predict the target variable, which is is the person diabetic? And so we've had one for that, and I think we had one for um, are you overweight, based on some other statistics. That was sort of another one. So we do these are another sort of project, a project style we do, which is like machine learning, predictive analytics kind of stuff. So those are pretty cool too. Right. So Michelle, okay. Any
Well,
questions on any of that stuff before we?
I actually have a question.
Sure.
Because this week, Charlie Wagner came to talk to us about data privacy. How are you guys dealing with that? Especially when I'm hearing, prediction of diabetes, things like that, right? Is that completely made up data, or is it, or when you say I'm capturing data from the webcam, right? I mean, how do you deal with the data privacy?
That's one of the reasons we've been working with our local LLMs. The majority, other than the quad cam, and even the quad cam video feed is public.
Yeah, that's on
I
YouTube.
think all of the data sets we've been using have been public.
Yep.
Unless they're working with a faculty researcher, and then we have run that through and de-identified it through our data team.
Yes. Yeah.
And then our projects have all been hosted or sourced from our GPU server, and so we're not pushing it out anywhere else. So
at some point, those applications would like perhaps to deploy them at scale, right? How would that, departing from local LLM to perhaps, bigger one that are publicly available, how will you deal with the data privacy? Or is it not something that we should be concerned about?
Data privacy, of course we're concerned about data privacy. I am not going to say anything else. I don't know who all's on that call either, right? For the recording. But no, data privacy. So as Mike said, he's on the app dev team. I'm on the data services team and app dev team for LAS. So data is definitely high priority on the things we do. Any of our interns that are working anywhere near or might possibly see any student data, they're all going through FERPA training and getting, a short little extra, lecture from me on ethics of working with data and all of that. And they have found that interesting too, just to think about that aspect of the work they're doing. But so far, other than we haven't really come across any of these apps yet that are great candidates for scaling. So as we go, even as we're looking at the proof of concept projects this summer and probably in the fall that are coming from our dean's office, those right now we're calling them proof of concept. So we're taking a subset of data from the public, OBFS Biz website and using that just as a proof of concept. One of the things I know that has been talked about with my boss, Bob Morrissey, is that where do we have the full-timers working on these projects versus the interns? And right now, all of our intern projects have really been proof of concept at the end of the semester. I'm surprised we have some of them still running. They're all being developed and on university resources. So web.illinois.edu has been a great place for us to stand up some of those. And then we've been using the ATLAS services on the other side. So that's a great question, Michelle. We haven't had to tackle that yet, but as we move forward, we may need to, because if we get interns who do great proof of concepts, right now it'll probably transfer then to our full-timer team to go through and finish out the scaling of it with our full-timers.
And eventually I can also see the need of bringing in the ethical implications of what we may be developing in the future.
Right.
So, right now you're saying, let's try to predict diabetes, right? But, maybe it's going to be extended to, let's look at your genomes and let's going to predict that you're going to develop that. It may have some direct implication that we are not thinking about right away.
Yeah, and
I'm not sure when to start those conversations with people who are, pretty big in that space.
well, and I think as right now we're working with just the undergrads who have ideas,
Which is great.
right? And so we're really kind of fostering that creativity and that ingenuity. That
Yeah,
is that the right word? Yeah.
Yeah, we're giving them
with the
experience.
undergrads. And as we have more faculty or who are interested in these spaces, as we work or support researchers, we've got a different infrastructure that handles like researcher projects, and I expect that those things will go through more of like the IRB and the research protocols that are out there. Mike has been working with one of our infrastructure guys, and our infrastructure team, is also supporting some researcher infrastructure. So I think we've got a pretty good tab on what we have right now. And then we've got full-timers who are working in some of those spaces. So as we transition, I expect that, we'll start to transition some of their standard practices into what we're introducing the students to. Even with, I think people were surprised when I was having my undergrads do some of the FERPA training, just to help make sure that they understand, and it doesn't hurt to start introducing those ideas early. So.
That's great. Can I ask another question?
That's fine with me.
Okay, very quickly. So fantastic learning experiences for your students, right? And for our students. Learning about the layers of the layers with you guys, professionals. Do you see, or have you seen any gap between what the students now are capable of doing and their advisor? No, because I'm just thinking, I'm just thinking about myself when I was really running a lab. I may have had an undergraduate doing an internship with you guys and coming back to me and say, hey, look at what I'm doing, but I'm like, I have no idea what you did. Right. So do you see that or not?
Mike, have we had any students go from us to researchers yet? A lot of the students Mike ends up with are upperclassmen.
Okay.
Yeah.
So a lot of them are juniors and seniors, and some of them with us who have been more advanced have stayed with us until they graduated, kind of tweedling around on their own stuff. But one of our hopes is to make these experiences available for more and more LAS students. So I've started some conversations with our LAS Career Services, and I'm meeting with our Office of Research tomorrow morning, actually, to figure out, can we establish more pathways to getting the students out there? As far as the developers go, I've got 3 full-time staff on our AppDev team. And right now Mike is working with some of these technologies, but they're technologies that we haven't really integrated yet into our production level operations. You know, we haven't had those types of requests yet. But I know some of our staff are kind of working ahead to try and be there. But one of the things that's interesting to me is getting the students paired up with professionals in the industry. And you know, research intensive units may have some different experiences and some different opportunities. In LAS, we definitely have researchers in LAS, but it's often different than like the engineering. A lot of these would probably fall with engineering faculty. Um, but Atlas is absolutely open and interested in talking to researchers who are interested in these spaces.
Sure.
And you know, we can help talk about a transition, or there is probably going to be some gaps between, you know, current staff and, you know, people coming out of school. I had the bachelor's of computer science as my undergrad, and I think there's something in some of these programs that like, one, I think they breeds a little bit of an arrogance, like, hey, I know this cool stuff and you're old, so you don't know this. But that's my own opinion, and I'm talking about my own experience. I don't know, because my talented programmers tend to stay up on what's going on. Now, where it gets into researchers and stuff, we may need to partner more. Partner more if we have researchers who are interested in these spaces.
Thank you.
But yeah, Mike has got some super cool demos. So Mike, do you
Yeah,
have
well,
one to start with?
yeah.
Or you
So
can tell about both of them and have them pick one.
yeah, so so this is a sort of different. We're taking a different direction in this talk now. So now it's sort of like I learned all this stuff by having working with these interns, and I wanted to apply it in my own, you know, in my own life, in my own work, and how can I use these tools personally, with that I've learned, and can I actually use it for kind of self learning and things like that. And so I have a couple examples. I thought I had more time, but like Michelle said, we can do both. I mean, I can go through both and then maybe quickly. Let's see. So let me share my screen.
One of the reasons we wanted to present these is because in our academic and learning environment, while Mike has been using them on his own personally, I think once you
Yeah.
see them, they will be very easy to make the connection of how others could use them in higher ed.
Yeah. So can you see my screen?
Yes.
Okay. So one of the things that I tried doing is, so recently I had to redo I had a driver's license, I had to redo the driver's written test. Okay. And so
He moved. That's why.
yeah, I was reading the book, you know, they give you that long book, and they say, okay, so here's some sample questions. They give you maybe 40 or 60 sample questions. And I'm thinking to myself, I got to read these books. There's only a few that I can memorize, and there's only like 60, but they could ask you like different ones from the entire book. And so I was like, maybe I could use this, like a large language model, to create something for me that would help me with this. Okay, and so I use Gemini, which is the current, I think, is one of the best models currently, Gemini Pro. It's free, and that's one of the reasons I wanted to try it. Is it's free, and as long as you have a Google account, it's free, and it's got a large context window, and you can use it to create apps. So I was like, okay, so why don't I take this book and create some sort of quizzing system for myself? And I wanted to try this experiment, see if it would work. So the nice thing about Gemini, like I said before, is it's got a very large context link, so you can upload a ton of stuff. So what I ended up doing is, so if you can see my screen, so here, this is the book. Let me see if it's going to load the image.
So you found a PDF of the book somewhere?
Yeah, the PDFs are all online for these. So you can, so here it is. So I redid this last weekend. So this is the Illinois rules of the road. And I had it, the first thing I said was, give me 20 written driver's test questions from the following text, which is this. And so here's what it did. So it was able to sort of ingest the entire book, and you can see how many tokens it used. It used 30,000 tokens, and Gemini has up to 1 million tokens. So this is fit easily within its token limit. So it tokenized the entire book, and so it's using the entire book as sort of in a prompt essentially. And so you give it 20 questions, then you have it do the thinking. And then you can see its thoughts here. So here's the thinking. So I turn that on. And the thinking allows it to sort of rehash and do like a chain of thought reasoning before it actually answers your questions. So this takes about a minute or so, but it's worth it because it gives you more accurate answers. And you can see it generated 20 questions from that book. And I have a decent probability that this is going to be, most of these are going to be okay. So I looked at these. I said, okay, I cross-checked some of them and they looked okay. And they tell you the page it's on. They tell you the answer. And these are all brand new questions that are generated from a large language model. Okay, so I told you that's great and everything. I didn't want to read. I actually wanted some sort of like an app. I wanted to do this interactively. And so I had it create an app for me that took all these questions and had me do spaced repetition. So if you don't know what spaced repetition is, that's sort of a system where you review sort of flashcards, and if you get them right, then you can select their difficulty level. And if you select based on a difficulty level, it will ask you at a certain time limit again. So if you answer hard, this question was hard, it will ask you more frequently than you ask it if you say it's easy question. So I had to first create some questions, then I had to prompt it with make a JavaScript flashcard app that I can use to study above questions. Use spaced repetition with easy, medium, hard gradings. And then I had so this prompt was iterated. So this is not my first try at this. So maybe my first try was this part of it, but I would iterate this prompt. I would see what it generate, and if it had problems, I would sort of address the problems in later parts of this prompt. So figure out the best strategy, include the first 20 questions, and the ability to easily add more in the code. So you could ask it, you could continually generate more and more questions and just paste them into the code. So put all code in one file, and for any libraries, load them remotely, use persistent storage, JavaScript's local storage if necessary, and minimize clicks where appropriate, make the app visually appealing and intuitive. Okay, so it makes a very simple app. And here, actually, here's a thought process. It's sort of chain of thought process to create this app, and they created an entire app for me. You can see here's the code. I didn't do any of this, and this is a one-shot app. So in one shot, it generated this entire thing, and then here's what it is. This is what it looks like. This is a simple app that drivers test, and right now there's only 20 cards, but you can see it creates the question, and you can click on it. Let me see. When must you notify secretary? So that's 10 days. If I click on 10 days, it tells me correct answer. And then I can select, is it medium, easy, or hard? If it's hard, like I said, it'll ask me more frequently. And I double check the code. I looked at this JavaScript generated, and it does work. So if you say this is a medium question, it goes on to the next one. Okay, so let me just pick a random answer here. So this is incorrect. Okay, and it tells you the correct answer, and it tells you the explanation. So like I said, this is something I used in real life. I had to create questions. I had to tweak a little bit. I had to tweak the prompt a little bit to get it to do this exactly how I wanted, but eventually came up with this, and it made a very like sort of easy, sort of efficient way to study for this particular multiple choice test. And this is the kind of thing where you're not too worried about the answers, or that the questions and the answers are completely correct, because there is a sort of you can get a few wrong on this test and you can still pass. So I wasn't super worried about, is this are all the questions 100% right? So that's one thing, you got to worry about hallucinations for sure. But like for this thing, this is kind of amazing to me that you can generate a working app like this with one shot prompt and just uploading the text of the book, the PDF.
Are you
And
running this? Are you running what kind of a machine are you running on this? Anything
this
fancy?
is this is a very simple app. It's you can look at
Running
this is
on a
all the,
basic laptop.
yeah, it's just on a MacBook, and you wouldn't even need that. I mean, you could just it's literally just HTML. Here's the questions it generated. And here's the code. It's very simple JavaScript. That's many lines. It doesn't give you a whole lot of code. It just gives you enough to make it work.
This is
And
cool.
so, yeah, and so I had a few problems. It still shows buttons before submitting answer. Also include a question counter, improve the context colors. So I had to kind of redo. This is something I had to kind of redo, and it will look at what I asked it, and it will say, okay, here's what I did wrong, and then it will regenerate the code. And so this is maybe the second version. And so this is what I did, and I used this to study for a real life thing, and it worked. It was actually really interesting and great. And this is it's a really good, like, a use case. This now, I quickly I can show the other example, which is the other example is sort of self-learning. So again, this is like a self-learning thing. Here, another example of self-learning. So what if I wanted to kind of learn reinforcement learning? So this is a topic in computer science and in machine learning, and I wanted to learn this paper. Well, this is a more of like a textbook, but I wanted to learn this reinforcement learning, and so I had it like I take a random example, a figure, and generate like an interactive visualization based off of that example. So see, so here's where I uploaded the text. You can see it generated 55,000 tokens, which is definitely within the token limit. So please see the attached file. I will ask questions about it. And so it says, of course, I will do that. And now I said, create an interactive, intuitive visualization based on a particular example in the text. And I gave the example by number. So it had to find that example and give the correct and make a correct app based off that example. So one thing I should note here is that's important is I did have to, so in this case, I do have to change the system instructions. And so you can see I have a long system instruction, and this system instruction has been iterated after I discovered certain issues. So this is a lot of things, a lot of times you have to do kind of this iteration of either the prompt or the system instruction to get what you want. But in this case, it's just like you are an expert artificial intelligence researcher who has years of experience in AI and ML and research and pedagogy. You pride yourself on incredible accuracy. So these kinds of things, telling exactly what you want. Again, the second sort of paragraphs are more specific. You always want to find them in LaTeX Markdown. So that renders in the browser, make sure LaTeX is correct, make sure you generate the right code, and these sorts of things to make sure that it doesn't hallucinate, minimize hallucinations. Okay, so I had it create, let me close that. I had it create an intuitive visualization on 2.13. So let me kind of scroll down to that.
Mike does math for fun.
Well, I wanted to learn this kind of stuff. So here's this example, 2.13. It's called the one. I thought this would be a good example of something that would be interesting to visualize. So it's a grid world, and it's got a grid system here set up that various values for the math here. And I had to generate a thing for it, an app for it. So here explain, and here's the app. Okay, so it's a bit of code, and so this is what it generated. Okay, it generated this graph, and it generates the explanations down here. It says try different values. And then I wanted to see, okay, is this actually correct? And so I looked up, if you compare these numbers to what's actually in the text, so you have the different values of 0, 1, and 0.9. And I looked and said, okay, 0.9 is 0 correct and 0 match. Does 1 match? And they all match. And so it actually found this right example. It found it in the text and created like a simulation, a visualization of this grid in JavaScript that I could run and look at. Okay, so I had to do something else. I had to do another one. So where is it? So what about 2.5? Figure 2.5. So that's this one. 2.5. Q learning. So that's going to be sort of this section here and this diagram here. And so I had to generate modify the code to include Q learning and figure 2.5. So it creates that, and here's the code it generated. And here's the Q learning example. And it has the same one, and it added this. This is the Q learning. And so it can run episode. You can run this, and you can see it work and see in real time. You can see the Q table changing. And I initially had some kind of errors with this, and I had to go in there and kind of figure it out myself and make sure that it was doing the right thing. And I verified that the equations were right. It was actually matching this algorithm here. That I double checked the code to see that this algorithm was matching, and it was in the code. So it definitely interpreted this. It read this equation and put it in the code correctly. And so you can see it running. And these values do match this table up here. Where is it? Down here. Yeah, down here. This table. It will match this table. So it's kind of amazing that I can create this example and I can reset it and have it do all this for me for just asking it to. I had to do, let's see. Did I have it? Oh yeah, I had to do similar thing. I had to show it. I in a later prompt I asked make it animated, show it what happens. And so here's what happens. It's showing the sort of what the robot, the agent is doing on each step here. They happen to be doing the same thing over and over. Let's try to reset it. So here's just doing something. You can see it's actually animating this thing, and it's animating the table as I run it. You can see it working, and it's doing something there. And so yeah, so this is sort of what I have the students kind of do, experiment with this. And so if you want to learn something, this is kind of really kind of cool thing to do with cool, we're in a university setting. And so for me, this was like really interesting and a good way, I think, for students to try and learn something is have the LM generate these these sort of learning tools for you. And then have you kind of understand, and actually going through these, checking to make sure that this code was right and making sure it matched this algorithm here, this Q learning algorithm, actually is helpful to learn because you're engaging with the material. You're not engaging with it necessarily with an exercise or something like typical in a sort of a class setting, but you're still engaging with the material in a slightly different way. But it's more, at least for me, it's more interesting because I'm seeing the thing visualized. I've done this with a bunch of other books and papers and things, and create visuals, and it creates really kind of cool simple visualizations that can be run in your browser and help you sort of to learn this stuff. So I think I'm out of time. Do we have? Can we go over or no? Because I have slides. I can talk about
We have
some.
some questions in the
Okay.
online chat. One question or comment is from, sorry if I mispronounced your name, is Zion. She said, "This is great. Thank you very much for sharing, Michael. Do you have any best practice to validate the generated content and check if it's correct?" So really she's asking for the accuracy.
Yeah, so that's sort of what my slides go into, but yeah, so there's no real way to do this unless you have sort of a resource available to double check this stuff. So what I do is I make sure that if I'm going to learn something kind of like this, it's not going to be too far out of my current level of knowledge. So I'm not stretching too far. So I'm only learning something that I can double check if possible, because definitely there's hallucinations, there's definitely errors. Some of these versions of this app here didn't run right away, so I definitely had to go and check and see what the problem was. So it does hallucinate, it does generate errors. And so what I would say in that case is, so when you're kind of starting to learn a new topic that's not too far out of your knowledge base, you can use the finding of errors and the double checking as another way to engage with the material. It's kind of like assuming, every textbook that you have has an errata, right? Has error list. Some textbooks have more than others, but it's almost like finding an error in a textbook. It's like it's giving you this either questions or interactive interactive visualization or some kind of teaching material. You want to make sure that it's correct, so that you go back to the source material and verify that it's right, and it's sort of like an exercise to help yourself learn it. And like I said, another way to engage with the material is to find the errors in these. And so, yeah, you don't necessarily want to trust all this stuff that it gives you. For the driving example, I was okay with having errors because you're okay to get a few wrong in that case. So I had to generate like questions and answers based off of other textbooks, and yeah, I definitely had to go back, and I was you're sort of suspect on some of the answers that gives you, the questions that give you, but that's a good place to learn. And again, why you don't want to be too far away from your field. So if I tried to learn like biology or chemistry, like organic chemistry, I had to generate like organic chemistry visualization. I wouldn't know if any of that stuff is right, because it's way too far out of my knowledge base. Like computer science, like programming something, or math or something like that, I could kind of work backward and say, okay, this is probably right. And so that's sort of what you have to do, is have an actual, like a separate, like separate knowledge, like an actual textbook. I can refer back to this actual textbook and double check that it's working.
Good. Thank you.
Thank you.
So thanks everyone for coming. I thought we were going to get the podcast demo, Mike, but we ran out of time. So
Yeah.
that's okay. We'll do it another time, maybe. So thank you.